Welcome to the Royal University of Phnom Penh. This unit is about the data collections. In these presentations, I will present you the learning outcomes of this unit, what the data is, the differences between data and statistics, the introduction to types of data, and data collection approaches. Upon the completion of this unit, you should be able to differentiate types of data, categorize data in according to the nature of data generated tool, and you should be able to apply appropriate methods to collect data. What is data? In short, it's a collection of measurements or observations divided into two different types, known as qualitative and quantitative data, which are further classified into four types data, such as nominal data, ordinal data, discrete data, and continuous data. For qualitative data, refer to words, image, observations, conversation, or photograph. For quantitative data, refer to numbers, tests, counting, or measurings. For quantitative, refer to data that can be measured with numbers such as duration or speed. This information can be further divided into discrete data and continuous data. For discrete data, whole numbers that can't be broken down, such as a number of items. And for continuous data, numbers that can be broken down, such as height or weight. In continuous data, can be further broken down into interval and ratio data. In intervals, data refer to number with known difference between variables such as times. For ratio data, numbers that have measurable intervals where difference can be determined, such as height or weight. For qualitative data, known as non-numerical data, that is categorical, such as yes or no responses or eye colors. For this information, it can be broken down or divided into nominal or ordinal data. In nominal data, the data used for naming variables such as hair colors. For ordinal data, data used to describe the order of values such as 1 equal happies, 2 equal neutrals, and 3 equal unhappies. What is the difference between data and statistics? Data refer to data sets or machine-readable data files. Data files for statistical software programs. Data can be analyzed and interpreted using statistical procedures to answer questions why or how. Data is used to create new information and knowledge, while statistics refer to statistical tables, charts, or graphs, or reported numbers and percentages in an article. A statistic will answer question how much or how many. A statistic repeats a predefined observation about realities. Statistics are the results of data analysis. They usually come in the form of table or charts. This is what a statistical table looks like. Here is an example of statistic in a table. The table presents the response to the question how many people has currently got a stable job. There are 5 columns in these tables. The first column refers to the response to the questions. The second column refers to the frequency of responses. And the third column refers to the percentage which converted from the frequencies. And the fourth column refers to the valid percents. And the last column refers to the accumulated percents. From the table, we can see two among the 434 people did not answer to the question. It equals 0.5%. And 382 people state that they have currently got a stable job. It equals 88%. And among 434, 50 of them say they did not have the job, so it equals 11.5%. Introduction to types of data. Qualitative data refers to information about qualities or information that cannot be measured. It's usually descriptive and contextual. Examples include someone's eye colors or the type of car they drive. In surveys, it's often used to categorize yes or no answers. Quantitative data is numerical. It's used to define information that can be counted. Some examples of quantitative data include distance, speeds, heights, lengths, and weights. It's easy to remember the difference between qualitative and quantitative data, as one refers to qualities and the other refers to quantities. A bookshelf, for example, may have 100 books on its shelves and be 100 centimeters tall. These are quantitative data points. The color of the bookshelf, red, is a quality of data points. How do we use quantitative and qualitative data in statistics? Once data scientists have a conclusive data set from their samples, they can start to use the information to draw descriptions and conclusions. To do this, they can use both descriptive and inferential statistics. Descriptive statistics help demonstrate, represent, analyze, and summarize the findings contained in a sample. They present data in an easy-to-understand and presentable forms, such as a table or graph. Without description, the data would be in its raw forms with no explanation. Descriptive statistics. One way data scientists can describe statistics is using frequency counts or frequency statistics, which describe the number of times a variable exists in a data set. For example, the number of people with blue eyes or the number of people with driver license in the sample can be counted by frequency. Other examples include qualification of education, such as a high school diploma, a university degree or doctorate, and category of marital status, such as single, married, or divorced. Frequency data is a form of discrete data as parts of the values can't be broken down. To calculate continuous data points, such as age, data scientists can use central tendency statistics instead. To do this, they find the means or average of the data point. Using the age examples, this can tell them the average age of participants in the sample. While data scientists can draw summaries from the use of descriptive statistics and present them in an understandable form, they can necessarily draw conclusions that where inferential statistics come in. Inferential statistics. Inferential statistics are used to develop a hypothesis from the data set. It would be impossible to get data from an entire population, so data scientists can use inferential statistics to extrapolate their results. Using these statistics, they can make generalizations and predictions about a wider sample groups, even if they haven't surveyed them all. An example of using inferential statistics is in an election. Even before entire country has voted, data scientists can use this kind of statistic to make assumptions regarding who might win based on a smaller sample size. Qualitative or categorical data. Qualitative or categorical data is data that can't be measured or counted in the form of numbers. These types of data are sorted by category, not by numbers. That's why it is also known as categorical data. These data consist of audios, images, symbols, or text. A gender of a person's, example male, female, or other, is qualitative data. Qualitative data tell about the perception of people. This data helps market researchers understand the customer tastes and then design their ideas and strategy accordingly.
The topics covered thus far have all been aimed at descriptive statistics. That is, describing the data we've collected. There's an entire other field of statistics known as inferential statistics that's aimed at drawing conclusions about a population of individuals based only on a sample of individuals from that population. Imagine I want to understand what proportion of all Udacity students drink coffee. We know you're busy, and in order to get projects in on time, we assume you all must drink a ton of coffee. I send out an email to all Udacity alumni and current students asking the question, do you drink coffee? For purposes of this exercise, let's say the list contained 100,000 emails. Unfortunately, not everyone responds to my email blast. Some of the emails don't even go through. Therefore, I only receive 5,000 responses. I find that 73% of the individuals that responded to my email blast say they do drink coffee. Descriptive statistics is about describing the data we have. That is, any information we have and share regarding the 5,000 responses is descriptive. Inferential statistics is about drawing conclusions regarding the coffee drinking habits of all Udacity students only using the data from the 5,000 responses. Therefore, inferential statistics in our example is all about drawing conclusions regarding all 100,000 Udacity students using only the 5,000 responses from our sample. The general language associated with this scenario is as shown here. We have a population, which is our entire group of interest. In our case, the 100,000 students. We collect a subset from this population, which we call a sample. In our case, the 5,000 students. Any numeric summary calculated from the sample is called a statistic. In our case, the 73% of the 5,000 that drink coffee. This 73% is the statistic. A numeric summary of the population is known as a parameter. In our case, we don't know this value, as it's a number that requires information from all Udacity students. Drawing conclusions regarding a parameter based on our statistics is known as inference.
The subset of qualitative data is nominal data. Nominal data is used to label variables without any order or quantitative value. The color of hairs can be considered normal data as one's colors can be compared with other colors. The name nominal comes from the Latin name nomen, which means name. With the help of nominal data, we can do any numerical task or can't give any order or sort the data. These data don't have any meaningful orders. Their values are distributed into distinct categories. For example of nominal data. Nominal data would be covers the information of color of hairs, brown, red, brown, or black, etc., or marital status such as a singles, widow, or married. Nationalities can be Indian, German, Americans, or gender of persons can be male, female, or others, and or eyes color like black, brown, and etc. So this information could be in the category of nominal data. Another subset of qualitative data is ordinal data. Ordinal data have natural orderings where a number is present in some kind of orders by their positions on the scale. These data are used for observation like customer satisfaction, happiness, etc. But we can't do any arithmetical tasks on them. Ordinal data is qualitative data for which their values have some kinds of relative position. This kind of data can be considered in between qualitative and quantitative data. The ordinal data only shows the sequences and cannot use for statistical analysis. Compared to nominal data, ordinal data have some kind of orders that is not present in nominal data. Here are some examples of ordinal data. When companies ask for feedbacks, experience, or satisfaction on a scale of 1 to 10 from their customers, or the letter grade in the exams A, B, C, or D, etc. Or when we ranking people in competitions, the first, second, or third, or etc. Or we refer to the economic status. For example, high economic status, medium, and or low. Or education level, for example, high education, secondary education, or primary education. This information can be in the category of ordinal data. Here's some comparison between nominal and ordinal data. The table shows the differences between nominals and ordinal data. Nominal data can't be quantified, neither they have any intrinsic orderings. Ordinal data gives some kind of sequential orders by their position on the scale. Nominal data is qualitative data or categorical data, whereas ordinal data is said to be in between qualitative data and quantitative data. They don't provide any quantitative value, neither can we perform any arithmetical operation. Where the ordinal data, they provide sequence and can assign numbers to other or to ordinal data, but cannot perform the arithmetical operation. In nominal data cannot be used to compare with one another. Ordinal data can help to compare one item with another by ranking or ordering. For example, in nominal data, we have eye colors, housing styles, genders, hair colors, religions, marital status, ethnicity, etc. Whereas in ordinal data, we have examples of economic status, customer satisfaction, education level, or letter grade in the exam, etc. Quantitative data. Quantitative data can be expressed in numerical values, making it countable and including statistical data analysis. These kinds of data are also known as numerical data. It answers the questions like how much, how many, and how often. For example, the price of a phone, the computer RAMs, the height or weight of a person, etc. fall under quantitative data. Quantitative data can be used for statistical manipulation. These data can be represented on a wide variety of graphs and charts, such as bar graphs, histograms, scatter plots, box plots, pie chart, or line graphs, etc. Here are some examples of quantitative data. The information related to height or weight of the person or objects, the room temperatures, the score and marks from the student exam or the student earns, times, fall under the category of quantitative data. The subset of quantitative data known as discrete data. The term discrete means distinct or separate. The discrete data contain the values that fall under integers or whole numbers. The total number of students in a class is an example of discrete data. These data can't be broken into decimal or fraction values. The discrete data are countable and have finite values. Their subdivisions is not possible. These data are represented mainly by a bar graph, numbers, lines, or frequency table. Here are some examples of discrete data. The information related to total number of students present in a class, cost of all cell phones, numbers of employees in a company, the total number of players who participated in a competition, days of the week, fall under category of discrete data. Another subset of quantitative data known as continuous data. Continuous data are in the form of fractional numbers. It can be the version of an Android phone, the height of a person, the length of an object, etc. Continuous data represent information that can be divided into smaller levels. The continuous variable can take any value within a range. The key difference between discrete and continuous data is that discrete data contains the integers or whole numbers. Still, continuous data stores the fractional numbers to record different types of data such as temperatures, height, width, time, speed, etc. Here are some examples of continuous data. The information related to the height of persons, speed of a vehicle, time taken to finish the works, Wi-Fi frequencies, or market share price falls under the category of continuous data because this information can be divided. Here are some comparison the differences between discrete and continuous data. Study this table give us some more understanding or some more information to better understand the differences between discrete data and continuous data. In discrete data are countable and finite. They are whole number or integers, whereas continuous data are measurable. They are in the form of fractions or decimals. Discrete data are represented mainly by bar graphs. Continuous data are presented in the form of histograms. The values in discrete data cannot be divided into subdivision into smaller pieces, whereas the value in continuous data can be divided into subdivisions into smaller pieces. Discrete data have spaces between the values. Continuous data are in the form of continuous sequence. For example, data related to total number in a class, number of days in a week, size of a shoes fall into the category of discrete data, whereas the information of temperatures of the room, the weight of a person, the length of an object, or etc. fall into the category of continuous data. How do we collect data? In order to collect data, we have to consider if the data is primary or secondary. Consider how to collect your samples. Consider how to make sure your sample is representative of the populations. Collecting data is when you gather information in mathematics, which you can then organize and analyze to answer questions. To do this effectively, you need to know about different data collection methods. The table shows you some method which you should use to collect data. For primary data or in primary data collection can be done by direct observation using data collection sets or two-way tables. This data is collected directly by the person who is going to analyze it. For the secondary data that is taken from a secondary source rather than collected directly. Secondary data sources could be books or the internet. For qualitative data is data in words. For example, the color of student hairs. Quantitative data is in numbers. For example, the age of students. For discrete data which variable can take specific values. For example, the size, number of students present in the class, number of books on the bookshelf. Continuous data, which is variable, can take any value within a range. For example, time taken by each player to finish the race, weight of each student in the class, etc. In data collection, you can collect data from the whole groups. The whole group is known as the population. An example of this is a census, which takes place every 10 years in most countries in the world to collect data about the people who live or work in those. The process of gathering this data is time-consuming, but it is very useful for planning public services such as healthcare. A more practical way to gather information for data analysis is to carry out a surveys on a smaller section of the population. The smaller selection is known as samples. There are some important points to consider when taking a sample. For representations, ideally, you want a sample to actually represent the whole population. Certain sampling methods, such as stratified samplings, are better for this than others. In sample size, the bigger the sample size, the more accurately it will represent the population. However, a bigger sample size means more time and money will need to be spent on the samples. Bias. Bias in data collecting refer to data which may distort the result of research, as it is not truly representative of the situation you are studying. It is very important to avoid bias in data collecting. It may happen when you collect data from a small subset of the population. Data collection methodologies. A methodology is an explanation of a data collection process. When carrying out research studies, the data collection process can have significant impacts on the data's qualities. Different methods of data collection have their own advantages and disadvantages. Each research methods must be considered to ensure that the person that is collecting the data processors, can make an informed decisions about the method of data collections to provide high-quality data for their research. Data collection technique includes questionnaires, including online surveys, interviews, focus groups, observation, or case studies. Here are some more techniques for data collection. We can use interviews, observations, surveys, and questionnaires, direct measurements, case studies and story of change, document analysis, the research literatures, for example, tests, secondary data sources, focus group discussion, photograph and videos, etc. Questionnaire and online surveys. A questionnaire or online surveys consists of a list of standardized questions about a specific topics. They can be distributed to a large sample of the populations and returned to the data processor quickly using data collection tools such as the internet. Questionnaires are one of the most common types of data collections, as they can be cost-effective, and when the questionnaire is well structured, can provide enough detail of satisfies the requirement of the researchers. Marketing campaigns regularly use the internet, specifically social media, to broadcast new ideas and products to the markets, often followed up by a questionnaire to provide feedbacks about the products or service that has been sold. A questionnaire can contain a mixture of closed and open questions. Closed questions have a fixed response that can be answered by ticking a box or selecting a value on a scale. Closed questions are used to collect quantitative data, as you can quickly determine the number of participants that select each option. Here is a questionnaire related to a closed question. For example, the question below is a closed question because the response can be only one of the options provided. When they were asked, "How do you get to school?" the respondents can tick one of the boxes and they cannot express their opinions on these transportations. And another example of questionnaire related to open and ended question. Open and ended questions are used for qualitative research where the answer to the questions is more descriptive and therefore it cannot be answered using a simple tick box. For example, the questionnaire below is an open-ended question because the response is more descriptive. When they were asked, "What is your opinions on the number of green spaces in the university campus?" we cannot collect information from the ticking box when we want to know the opinions of the participants or the respondent in the surveys. So the respondent have to write their own opinion. And we're going to use these data for qualitative research. There are limitations with questionnaires compared to other data gathering methods. One of the main issues is the lack of respondents. Participants in the research studies usually need an incentive to complete a questionnaire. This may take the form of an external motivators, such as a discount or free entry into a prize draw, or there could be an intrinsic motivator, such as a strong emotional response or feeling of charities. Without incentive, research studies can struggle to collect enough data for their research to be of any significance. Another limitation of questionnaires and online surveys is the fixed schemes of questions, which does not allow participants to elaborate or explain further on their choice. It is also important that the participant understands the question that is being asked, which the data processor cannot check if they are not in attendance when the questionnaire is being answered. This can lead to unanswered questions or answers that are based on a misinterpretation of the questions. Another method of data collection is interviews and focus group. Interviews are usually conducted between the researchers and an interviewee. Interviews provide a chance for the interviewees to elaborate on their answers in more details, which may provide more information data. However, interviews are time-consuming and more costly than other qualitative methods of data collection. Focus groups allows the group of participants to answer questions while being able to listen and share ideas with other members within the group. Focus groups are useful as they can be more time efficient and informative compared to other data collection techniques. However, the dynamics of the individual members of the groups can skew the results. To minimize the risk of a biased data set, the participant should select a using an appropriate sampling techniques. This important for any research study being carried out. We can also collect data through observation and case studies. Participant observation is a real data collection technique to collect real-time qualitative research. For example, a social experiment is carried out on a group of 6-year-old children into their communication techniques with one another. By observing their behaviors around each other, researchers can recognize different methods of communication between the children rather than through difficult processes such as an interview where the children may not understand research questions or may not be able to explain communication techniques with their peer to the research providers.
Data collection methods are So you've decided on your data collection methods. Now you need to plan exactly how you use them to answer your research question. Your data collection procedures are the specific steps you take to gather data that's consistent, accurate, and unbiased. To plan your procedures, consider these questions. How will you define and measure your variables? How will you ensure your measurements are reliable and valid? How will you select and contact your sample? This video will focus mainly on quantitative research, where it's extra important to have a systematic plan for collecting your data. Hi, I'm Jessica from Scribbr, here to help you achieve your academic goals. First, precisely define your variables and decide exactly how you measure them. Some variables like height or age are easily measured, but often you'll be dealing with more abstract concepts, like satisfaction, anxiety, or competence. Operationalization means turning these fuzzy ideas into measurable indicators. If you're using observations, which events or actions will you count? For example, to measure students' participation in an online course, you could record the number of times students ask and answer questions. If you're using surveys, which questions will you ask and what range of responses will be offered? For example, to measure teacher satisfaction with online learning tools, you could create a questionnaire with a 5-point rating scale. You may also choose to use or adapt existing materials designed to measure the same concept. For example, to measure math skills, you could administer a math test created by educators. So, are you measuring any abstract concepts that need to be operationalized? Then you should also consider the validity and reliability of your measurements. Reliability means your results can be consistently reproduced, while validity means that you're actually measuring the concept you're interested in. For valid and reliable results, your measurement material should be thoroughly researched and carefully designed. Plan your procedures to make sure you carry out the same steps in the same way for each participant. If you're developing a new questionnaire or other instrument to measure a specific concept, you might want to run a pilot study to check its validity and reliability in advance. If you're testing a cause and effect relationship, you also need to think about internal and external validity. Internal validity helps you establish causality, while external validity means you can generalize your results to other settings. Both can be impacted by your data collection procedures. Check out our article to learn more. You've already defined your population and chosen an appropriate sampling method. Now you need a concrete plan for how you recruit your samples. That means making decisions like, how many participants do you need for an adequate sample size? What inclusion and exclusion criteria will you use to identify eligible participants? How will you contact your sample? By mail, online, by phone, or in person? If you're using a probability sampling method, it's important that everyone who's randomly selected actually participates in the study. How will you ensure a high response rate? If you're using a non-probability method, how will you avoid bias and ensure a representative sample? Now there's just one more step to finalize your research design. In the next video, I'll help you figure out your data analysis strategy. See you there!
After you have gone through these presentations, it is very important to do assignments. Direction. Prepare a data collection tool to collect information of people using social media for educational purposes. Your samples are from the students at a high school and universities. The total samples are 50, and the question should be people age, genders, duration of using or spending time with social media, and preference of viewing events. After having collected data, you should classify your data according to their nature, either qualitative or quantitative data. develop charts or graphs to represent your collected information. Thank you for attention.